evening, everyone. And I see a lot of faces who are not familiar to me, so I'm assuming that you are from outside of Ryerson. So welcome to the Department of Architecture Science and welcome to our lecture series. Today we're very fortunate. We have got speaker from Switzerland, Christoph Meier. And Christoph Meier is an executive manager and board president of Ryerson Holz. He is accomplished structural engineer, and he has been involved in complex structures in all materials, concrete, steel, and timber. And his team at Ryerson Holz is specializing in timber projects which are done all over the world. The group delivers broad range of projects from long-span domes, museums, residential and commercial building, multi-purpose halls, and it goes to geometrically elusive free-form construction. And Christoph will be presenting today the work which he and his group did on office building for Tamedia Zurich by very famous architect Shigeru Ban. So please help me to welcome Christoph Meier. Sorry, before I give him the podium, I just would like to acknowledge that today's lecture is sponsored by Canadian Wood Council, and we're very grateful for your support.
No, okay. Thank you very much, Stephen, also for this invitation. It's the first time I'm here in Canada, and I enjoy it very well from day to day. And I hope it's not the last one to be here. In our timber team of about 15 engineers and technicians, realize complex projects around the globe. Of course, for us, wood material is sustainable and beautiful and the best. This is a challenging specialty of our office, and I'm going to tell you something about this work. I would like to explain briefly how I came to be here. During the holidays in the south of Switzerland or in the north of Italy, in a vineyard called in Switzerland Grotto, I discussed whether I should take up the challenge and accept this trip to Canada or not over a glass of wine with my wife. Canada is a popular country for Swiss people, wishing to emigrate and wanting to experience the great freedom of this country. So I said to myself, if not now, then. After the second bottle of wine, the decision was clear. It's a piece of cake for you. This happened in spring. From then on, the clock started ticking for me. This clock is a particular symbol of the actual topic of this lecture. Means precision and Swiss quality. These are two important basics for the success of all the complex wooden structures which we are allowed to design every day. Using examples, I would like to show the development and our journey. This from the perspective of an engineer who had no idea how to solve his challenges at the beginning. Essential to his extreme development are primarily the creative ideas of our architects, I know here are a lot of, who inspire us again and again to tackle something new. In particular, Shigeru Ban, who is an absolute star architect for us, respected and trusted. If there were no architects, we would not be where we are. The first challenge was born about 10 years ago. Shigeru Ban won the competition of the Centre Pompidou in Metz, a museum for art in France, with a somewhat unique form and a wooden basket roof. I saw this model outside. Yes, plus minus the same. Now, what was the inspiration for this project? A straw hat. You might ask, what does a straw hat have to do with complex timber solution? This was the start for Shigeru Ban and his team. He designed a straw hat inspired roof over 3 100-meter long tubes. 3 100-meter long tubes, which make up the museum. You see it here on the model. In this difficult geometry, the challenge was to bring the individual parts through the other and frictionally connect them. The design engineer solved this with different nodes and a kind of board staple, which are then bound together with a lot of screws. You see it here in the middle. But since everything is bent, sloped and twisted, this really could not function, and we decided to work it out. Together with a carpentry company, we came up with a variation that included the following improvements. It's easy to do this in straw, but how in wood? Our grey eminence, our guru, Hermann Blumer, analyzed the structure with rough calculations and set our team and himself under pressure by posing challenges. The goals were reduction of the wooden volume of this project to a 1/2. This was very important for the budget. Simply connection method of the beam, which is possible in all position, twisted diagonals and so on. Easy installation, this means also low cost. And of course, quality and durability. The brilliant idea for the solution of these problems came while waiting for the train at the railway station. Engineers are accustomed to analyzing their environment, not always, but often. The train lines are often built with lattice girders in the system Virondelle. These are easy and economical, especially for large spans. Using this inspiration, we could solve our problem, as the beam will pass each hour. Of course, for these things, no standards and regulation exists, and definitely not for timber. To convenience the test engineers and also to confirm our theories, a variety of tests were required. Here we see the support consists of two braces, bolts at intermediate and shear connectors between to increase the stiffness. Now what was the result of these tests for bending and deformations? So we could confirm our theory and adjust our static model. The static model for the freeform roof was very complicated. No less than 35,000 bars were modeled precisely for their function. Beside the usual loads combination, also 100 snow and wind load cases had to be considered. The capacity of our IT were pushed to the limits of what is possible. To keep the overview of this volume of data took many, we say in Switzerland, smoking head and night shifts. Approximately 18 kilometers supports were milled by CNC machine and delivered in about 3,000 units on the side. And when you look on the left in this staple, you see all these pieces. You have to know what's up and down, and you can turn it on all sides, and it's not so easy to say where it is and so. And it was a genius idea of the positioning of these pieces from the carpenter. Without any plan, you could find out the exact location using a number code in the front here of the beam. The whole process of the static calculation of the geometry to the material producement and production ran totally electronically. The roof was mounted in individual layers. The geometry allowed no tolerances, which would have made assembly impossible. This was our risk. The longest line was approximately, one of this layer here, was approximately 90 meters long, and the tolerance was actually in a millimeter range. Problems happened only at the interfaces with our trades such as steel and concrete. Their dimensional tolerances were very large. The surface area of this roof is approximately 9,000 square meters. The free span from column to column up to 30 meters, and the top of the steel ring is at the height of 45 meters. First, the entire wooden structure was erected, and only then was the membrane attached. Assembly time was about 6 months. One difficult was the direct weathering of the construction during assembly. The parts were provided with temporary paint, so we could protect the timber over this time. Here you see a picture from inside with a view to the city of Metz. And here an example of an exhibited object, never I think a mind map nor a sketch of mine, but maybe we could something else. And 2010 was the official opening, but there was a continual audience even during the construction period. Buses with interesting people came almost daily to the site. For the opening, Mr. Sarkozy himself did the honors. But for us, however, satisfied customers are much more important. Here you see Shigeru Ban and John Degastine, the local architect on the right side, with a smile. That's our goal. This was our start to a new world of wood constructions. The possibilities were limitless for us, and our ego became inflated. But we were soon brought back to earth. In the follow, they have often taken part in competitions with Shigeru Ban and of course not always won. Here you see an example of a pedestrian bridge in Paris. Then a pavilion for an expo. It's a little bit fantasy. An airport building, and I said it also yesterday when I came here to Toronto. This solution looks a little bit warmer and nicer, I think, than this grey construction, but it's my point of view. And typically, you see always this cross-beam construction and this free-from building. Then, once again, a success. The new clubhouse in Yeoju, South Korea. We realized a roof support structure for this exclusive golf clubhouse. The difference to the Metz project is the range structure, and all supports were in one level. So no horizontal supports like we had at the Metz project, so even a bigger challenge. This means using cutouts in the nodes by the beams, the only way to bring these pieces together in one layer. The roof area is about 2,000 square meters. The distance from column to column approximately 9 meters. The column looks like a T that is needed for tee-off in a golf course. The fire resistance of this construction is about between 30 and 60 minutes. On the same date as the installation of Metz and Korea, Shigeru Ban won the competition for a new building in Zurich, the Tamedia project. Finally, a project in Switzerland and not so far away, of course for me, not for you. A geometrically simple, at least at first sight, means no longer a challenge for us, but we were also wrong. The targets we are able to directly read out from the daily press. The headlines were: intricate structure of wood and glass, sustainable contribution to architecture, CO2 neutral and environmentally friendly, and so on and so on. The idea were also presented in a model. Wooden stick composed as mechanism, without any metal and glazed on all sides. These were the challenges. The basic structure is carrier trusses, strictly geometrical, composed bionically. You see it a little here in this note. In bone-like nodes, an oval node is inserted. This gives the connection a certain stability and a framework. The building is located in the city of Zurich, in a prominent location next to the river seal, you see it here, and close to the main train station, and in the near of the Stoke building, where you can lose or win your money. You know Switzerland. So, and I said we have two parts of building. One means SQA, it's I tell it later, and one the W15. The project contained two different building complexes. The first part of the project was to build on an additional floor on the top of a 100-year-old building. You see it here, this 100-year-olds, and we have these 2 floors upper. The material wood, of course, particularly suitable for the low depth weight of the construction. The dimension in transverse direction is about 20 meters. The arched roof was originally planned with diagonal cross beams like we saw it before by all these competitions, but was simplified to save costs. The vertical load of this increase had to be derived in outer facade and in the center line. There we have a steel grate used. You see it here a little downside. This information is only for students only. So let's move to the main construction. Here the main dimensions are shown. 2 basement and 7 floor upper. This only small, but it's one. In width from 3 to 11 to 3 meters, 3, 11, 3. And the maximal height of about 24 meters, just below the high rise limit. In the front, where the main entrance is located, the angle determined by the side boundaries. The stabilization is provided by 2 concrete cores and horizontal floors sheets. As you see here, one, and here the other concrete floors, and here all these sheets. A big danger was the fire in this building. The authority didn't not grant permission first. The fire load potential was too great. So we proposed to do the whole construction in oak. Because oak has a different fire capital number than spruce. You know that's the reason why oak burns longer in a chimney than spruce. But the most important thing for me was that we also planned without metal compounds, so specified in the model. Since we were not used to do this, and we had to looking for new ideas. We copied an example that we all know for this problem. Based on hole reinforcers for paper in a ring binder folder, we developed plywood deposits in the primary beams and support. From my point of view, the creation of a one-to-one model for such task is very essential. Furniture in a large format is going to be reality when you can feel and touch it. So every detail was discussed and determined exactly with the client and all planners, especially with Shigeru Ban himself. The wooden selection ranged from oak and ash and white pine to normal glulam in spruce. Oak, we heard it, because the fire resistance is much better. Ash has a better strength property and looks nicer, more appealing. At the end it was spruce. The strain and the laminated wood came from Austria and are grown about 1,500 meters above sea level, with the characteristic fine structure of the annual rings and little branches. Here you can see the principle of the connection between beam and column. Beech plywood was glued as whole reinforcement. Here and here. The reinforcement made of wood are not visible introduced. The power transmission works in the same way as the architect's model, with a novel stick also made in plywood, beech plywood. Now, the manufacturing tolerances were a major issue. From the view of an engineer, the desire was, of course, the absolutely minimum tolerance, 0 mil. And the manufacturer naturally wanted as much as possible. No slippage occurs in the connection system, and additional deformations were the critical points for us. So we always defined in the static contact points with 0 mil, and on the other side with 3 or 4 mil. Means by the column on the underside and by the beam on the upper side 0 and the other one. Here are some pictures of the production of one column. The length of one piece was about 20 to 21 meters. The cross section about 44 to 44 centimeters, and the weight of one piece 2 tons. The surface were not treated and only with a temporary weather protection. All the parts are wrapped with foil, so discoloration could be prevented. The sensitive parts of beech were additionally provided with a coating against moisture. You see it here a little. As a result, shrinking and swelling could be prevented. Now in the following, I illustrate some interesting details about the high precision. Many components penetrate a fire compartment 30 or 60 minutes. So all window frame had to be cut out. In this cutout, a plaster board is glued inside and afterwards covered with a wooden veneer. Of course, the staircase must be as inconspicuous as possible and have a lot of transparency. Specifically, the cantilever and overhang platforms and staircases are built in steel. Of course, with only one fixed point on the left side, the rest is overhanging. To watch the assembly was very interesting, as void and first fixed point at the concrete core was used. Here the first frame was assembled as complete section with a mobile crane in the correct position. Then the ovals and the ceiling elements laid in. This framework was used again as a template for the next, and so it went on in a weekly rhythm. It was really sensational, as the parts like Lego or Meccano could be just plugged together. I still get goosebumps, you say, goosebumps, when I think about it. In the columns, the base plates were implemented for the facade construction. And the facade profiles matched very well without any tolerances. Every detail has been maintained and developed with the architect. The soffit is made so that the metal sail can be installed with acoustic and cooling elements. The slab edge was tapered to the facade side to bring as much light as possible into the room. You see it here a little. All installations were performed in a double raised floor on the top. Sprinkler, lighting, heating and cooling had to be conducted through the ceiling. The box girder ceilings made of wooden material are filled with sand and insulation. We had to design and plan the exact position of all these points. Approximately 3,500 holes had to be drilled, precisely coordinated. The fire resistance of the ceiling is 60 minutes. Corresponding penetrations were required. I said it before, one challenge was that the supporting structure penetrates a glazed section which is built with 30 or 60 fire resistant. To prevent the fire at the glass fiber, connection plaster strips were always glued on the structure and covered with veneer again. When you look exactly, you see here a strip with a gap. Here is veneer and here is the timber normal. And it was a very perfect work. And this means also for these ovals here. It was very high. From the outside of view, the building appears relatively simple and metallic. On the south side of the building, on the side of the river seal, glass shutters were implemented. The rooms behind are given the feeling of an open balcony with this effect. These offices are used for meetings and conferences and breaks and are very popular. On the left-hand side, you see the open shutters. Some of them could be open over 2 floors. At night, by lighting the rooms, the wooden structure is much more visible than during the day from the outside. When you enter the building, you are on a special stone ground floor. Stones from the river, cut and ground like terrazzo floor. This was the most expensive part of this building. Not the wood. The entrance was generously designed in terms of space to create an imposing first impression of all visitors. The transition to the concrete core are detailed and styled as well. The ceiling soffits contain all installation, acoustic, heating and cooling, sprinkler, everything. The transparency and easy, I think, is very impressive. The owner and his staff members are enthusiastic and confident even after 2 years. The employers were skeptical at the beginning of this building type, but not now. The interest in this building is very impressive. There will be about 100 tours a year, and the demand is still high. Maybe if you are in Switzerland, please get in touch with me and I'll show you these nice things. Now in the second part, I would like to give you a little overview of our current activities with Shigeru Barn and our works with wood. Here we lay again a challenge to gradually increase the requirements. Swatch is building a new headquarter and Omega a new production building, and this of course in wood. The planned museum located between the two buildings and will have a conference room to fit about 500 people. This is a museum, you see it here as a museum, and here is the conference room. This building with this freeform structure has a transparent and insulated outer shell. The office floors are open in this great free form space. Here a visualization aerial view of this building. You see here this is the headquarter, storage and offices. It looks like a little bit a snake. And here over the building goes over the street, and at the head is the conference room for this about 500 people. This is the museum, and here is the building for the Omega fabrication. George Clooney. I showed George Clooney because the ladies are here. And the other part would be Nicole Kidman. Looks a little bit skeptical, but will probably soon be able to participate at the advertising at the official opening. I hope so. And my wife too. The plan is to complete this building about in 2017, plus minus 3 years. I said plus minus. Not 2070. The subparquet structure is formed using cantilever beam diagonally crossed. The carriers are constructed precisely in different cross beam positions. You see here a principle of these layers that are 1, 2, 3, 4 layers, and you stick it only together. Of course, without any metal. Then a totally another thing is a resort in Turkey, not with Shigeru Ban, with Norman Foster, London, and you see also it's a hotel resort with villas and spa and so on, everything what you need when you have money, and with also with this grid shell in the same art as we saw it before. And another spectacular building we are going to build in Paris, the outer structure for an opera house, and this is also a Shigeru Ban project. The installation should be completed in 1 year. Again, we will apply new connection technology and put everything together without any metal. Noble structure, work in wood and only in wood. So came to Europe and visit us. We would be more than happy to show you around. Very thank you. Yes, I forgot it. Today I was at the art gallery by the Michelangelo, and at the end I make a picture of this, and here are a lot of students, and here you can see I'm still learning, and I want to say you, it's for everyone, but learn in wood, it's important. Okay, now I'm finished. Thank you.
Would you take any questions?
Yeah, when you have. I hope I can. My English not so is a little bit small, but I hope I can answer. You want to drink a beer? I said it before. For us, we are only engineers, and the ideas come from you, from the architects, and I think what makes the difference from a normal engineer to a special engineer, when you have the same feeling with the architect, and you can understand what he wants, then you have good solutions at the end. And it's it could be a Canadian architect, like a Japanese, and so on. For us, we are happy to work with such people like Shigeru Ban, and there are a lot of other, they can these things also. I don't know if I is.
My question was just one of your favorite buildings in China or Japan or
No, it's not for us. We are build also small houses. It's not so. Yes.
Did you ever have to convince Shigeru then to change his design?
So I meet him maybe once time a year, but normally it's Shigeru Ban is an eminence, and our guru is Hermann Blumer, and they have the contact between, and we are one layer upper, and by the Tamedia project runs about 5 years. It was a hard work for me and my team. And Shigeru Ban has 3 offices, one in Tokyo, one in Paris, and one in New York. And he always chat, I don't know in which direction, but it was normally 3 or 4 weeks rhythm. He came to Paris, and we had every week or every second week had we meetings in Zurich, and he has his not students, I say Atlate, I don't know, his guys who have to work it out, and when he was in Paris, you have to change something. This was you can feel it, and it's a very impressive and wonderful man. And when you have, I don't know, when you see him, I'm sure you are happy. That's in a small English, I
I'm
hope.
sure he learns so much from you, your techniques, and I mean the techniques that you come up with inspires
Yeah,
future
yeah,
designs. Because the projects that you showed us, each one uses a different joining technique. That was really interesting.
yeah, yeah. He's where he, you know, his first project was with cartoon paper, religion, and it's always very simple. And like uh, this model with these wooden sticks, and you have to understand how and why he is doing, and to do is in a bigger form. It's not so easy. There's a lot of work, of course, but afterwards you say it's simple. And why did I have so much hours? It's always so. But when you arrive this, then you are very happy. Yeah, yeah.
How does the project in Zurich relate, like, how is it cost-wise compared to steel or concrete construction, same size?
Of course, the cost was a very big goal, and it is not cheaper. It's expensive. I can't say exactly how much it is, but the whole building costs were about 50 million francs. It's in Canadian dollar, I don't know, 65, no, 660 maybe. And for example, all these installations, heating, cooling, air, and so on, costs about 15 millions. And the wood construction about 6 million. And now you can say, oh, maybe when you made it in concrete, it's 1 million less. But the different, I think it's not so much. And of course, this was a big discussion all the times, and it was not so easy. But it's Shigeru Ban, that the owner always says when Shigeru Ban say is we need this, then you have to do it. It was so, really. I always said it's too expensive and so on. You know it. The owner say, I will it and finish. It's like the floor with the stones. And it's really when you stay inside, it's another feeling, and you know it's not the cheapest solution. When I see all his concrete towers here, it's not the same. I can say you, it is. Yes.
You spoke a lot about Shigeru Ban, but I know on a couple other projects you worked with design and production with Coventry, and I was wondering, especially with the canopy at the concrete mats, what was the collaboration with them like? Did you use the same digital model, or was it a lot of sort of feedback?
Yes. Design to production is a very also is one of the important part for our work. Between it's a connection between the architect's model, our engineer's model, and the carpenter's model, the manufacturer. And design to production has a very important function to bring all these informations together without any paper, totally electronically. It's Now, you saw it's the same by all these freeform projects. It's very important to have some guys who know to analyze all these complex geometry. I hope you understand me. Yeah.
How were the wood then? Was it like heated and, or was it, did you create a wool?
The walls, or what?
No, I just mean like the wood pieces. How were they shaped? Did you take the straight piece and bend it?
Everything. When you good by Tamedia, it was only straight, but by Korea, for example, or the same afterwards by Swatch, you have to find out what's cheaper. Do you take a straight one, a little bit bigger, and mill it afterwards, or do you curve in one side or double curved? And that was a very important work of design to production of these guys to analyze all these things. And it's a big process because we as engineers, as I say, wood is absolutely straight and is bad on the other side. And we have to analyze and say when you have more than 5 degrees cut out, you have to change to one bandit or to double. That's a big challenge. It's not so easy. Yes?
You mentioned something about the fire rating.
Mm-hmm.
Was that fire rating theoretically determined, or actually you did some testing?
No, we have for the fire, we have our standards. I don't know what's here in Canada. You can calculate this. You say I have that's one part, while the columns by the Tamedia project are relatively fat, I think. It's 44 to 44 centimeters. And the resistance of these columns are 60 minutes. And approximately in 60 minutes, the section burns about 1 millimeter. It's a little bit less, but 1 millimeter is 1 minute. And you can say in 60 minutes you have 6 centimeters. And yes, and the rest is always standing, and the resistance is always given. But we have strictly these standards, and you can calculate.
So I guess you're saying that your standard tells you that for wood, 1 minute per 1 millimeter?
Yes.
Is that your standard tells you that? So
Yeah.
you can basically design any piece of wood and
Yes. Yeah. It's overdone. Yeah. Really. Exactly.
and then so then from a structural design point of view, you would simply
Yeah.
work on the
Yeah.
for 60
Yeah.
minutes and what strand is left at that.
Yes. Yeah. But also you have exits and escapes floors. There is no burning material, of course, is needed. That's, I think, the same here.
Thank you very much.
Yeah. Thank you.